Hello viewers and welcome to a new STM32 World tutorial video. I actually originally planned to make this a short or even perhaps a rant, but I changed my mind. This one is important enough to constitute a full-blown tutorial video. Today we are going to talk about GIT or JIT. I tend to pronounce it JIT, but I think the correct pronunciation in English is probably GIT. Doesn't matter. GIT is a distributed version control system that was originally developed for supporting the development of the Linux kernel by Linus Torvalds, the guy who initially wrote Linux. And now I think it's probably the most important tools that you will have in your toolbox. We have talked a lot in these videos about debuggers and development and IDEs and all that kind of thing. JIT is by far the most important thing, the thing that ties it all together. So today we will be talking about JIT. Now, I cannot count the number of times where I have seen in a forum or on Facebook or on anywhere else, I have seen somebody say, "Oh, I got a problem, please help me." And then they dump a zip file at best, or even worse, they might cut and paste some code snippets and say, "Please help me." And I mean, the problem is, it's just a waste of time. Now, you are not wasting my time if you're doing it because I'm not even going to look at it. It's that simple. So you're just wasting your own time and you're not going to get any qualified help whatsoever. Now, if you want to work with people online to develop your code or get help or anything, learn to use JIT or Git. Learn to use it. It's not optional. Just do it, or you won't get the help that you're actually asking for. So today, I am going to go through an example of how you should use JIT, and uh, I will show two examples. Now, I know I know a lot of users are using Windows and a lot of users are using Mac and whatever. I use Linux and I can only show you how JIT works on Linux. Now, I'm sure it works exactly the same on the others from a command line perspective. There might be some kind of graphical interaction. I'm going to show you one today, but that is just one of them. I'm sure there are others, and I cannot help you with that if you choose to use something else, that's fine. I mean, please by all means do it. But what I'm going to do is I am going to use the command line here to show a typical use case and a typical workflow. Now, using JIT essentially consists of two things. The first step is that you clone a repository that is shared online. You could use JIT purely locally, that's fine, but normally you would clone a repository from some online repository, and then you would work on that, and then you would commit your changes to the JIT and to JIT, and then you would push those changes back to the remote server. That is a typical workflow. When you start on a project that you already cloned before, the first step you would do is you would clone the changes that has in between been made, possibly by others, on the central repository, and then you would modify them, commit, and push. So pull, commit, push. That is the standard workflow that you use all the time. Now, I do a lot of code that I do on myself. I am not sharing it with others. I'm not working with others. I'll still use JIT because I have more than one workstation. I have a workstation in my office. I have a laptop that I carry around, and I use JIT for that as well. I mean, rather than carrying a USB stick around or whatever to share the file, I just use JIT. So I will pull when I start working, I'll pull, I'll make the changes, I'll commit, and I'll push the changes back to JIT. Now, that is fine when you're working on yourself, but what I'm going to try to show you now is how you can work with the code that I am using in my usual video. At the moment, I'm actually working on still my music player. I'm trying to put a display on it, so that's what is going to happen in the future. I also talked about putting MP3 support into this music player, and I would show you today how I would actually go about doing this. Especially if I was a third party. So essentially how I would suggest that you do with these things. First of all, you go to GitHub, which is by far the most important, and you browse into the STM32 world, STM32 fun. That is a repository where I put the code of all. Now, this is under an organization called STM32 world, but I also have a personal GitHub repository which is there, github.com/lbthompson, and that is where I put 90% of my stuff. A lot of this stuff is public, some of the stuff is private, but that's where I put the stuff. So I'm going to develop a slight schizophrenia today, and I'm going to be both STM32 world and myself, and I'm going to show you how I would, as myself, work on the STM32 fun repository. Now, the first step is, of course, to sign up for GitHub. I'm not going to talk you through that. You figure that out by yourself, but go to github.com and sign up. I think most people will probably just use their Google account. I think you can do that. But never mind. Find a way to sign up for GitHub. Then if you want to work on it, I actually do it almost by default. If you go to my personal account, you can see that I have 480, is that 67 or 87? There's a glare in my screen there, I think it's 87. 487 repository, and most of this stuff is stuff I never touched again. I just used it at one point and wanted to have a look at it, and that's how it ended up there. But what you do is you start by clicking fork here. You create a fork in my STM32 or the STM32 world STM32 fun repository. You create a new fork. I want to create it under myself. You can also create it under another organization you are a member of, and you can call it pretty much whatever you want. In this case, I'll just call it STM32 test to make sure that they are different. I will essentially, what that does is when I create that fork, I'll do that. Now it actually switched to the LB Thompson. I don't want that, so let me go back to the STM32 fun. So now when I'm talking about this, it can get a little bit confusing. So have a look up here which account we're actually using at the moment. So now we are going to my LP Thompson, and if I look at my repositories now, you can see that there is a new repository called STM32 Fun Test. It says up here it is forked from STM32 World STM32 Fun, and that is all good. But it is, for all intents and purposes, exactly the same. Where it is different, I don't know if you noticed that when I cloned it, I only cloned the master branch. This one actually probably have some, it doesn't really have any, but it could have other branches, it could have other tags. I only cloned the main one. So this one will not have any of that branch history that the other one have. You can see also, because I'm working here on a fork, it will say that this branch is up to date with STM32 fun master, the master on there. So let me do the first example to show you what can happen. Now let's assume that you did this and then you went for dinner or whatever, you come back a little later. Meanwhile, somebody else, and now I'll do it as the STM32 world, I'll just do a little change down here in the README file. I'll commit that change, commit changes. So now this README file has been updated. Now you will notice that, and again, you have to imagine that this is two different locations, two different persons, right? The STM32 world, which I'm working as here, imagine that I come back later here and I check the site, and you will see that this branch is one commit behind, because a commit was made behind my back, so to speak. So what you can do is you can sync the fork here, update branch. So this branch is out of date. So if I update the branch, you will see that now it has been updated, and you can see this. I didn't show it was there before, but it was. The test was there before. So this is essentially how it works with the online stuff. So this is what you can do to the GitHub user interface. Now, if you want to work with this in any meaningful way, what you will do is you will click on the code button here, and you will see there's a URL, and you should use SSH for this. I'm not going to go into how to set that up and how to set the authentication up, but that's there are other ways you can do this. So I copy this URL, and then I like to use command line. So let's try to go down here, and I'm not going to keep this around, so I'm just going to go into my temp folder, and I'm going to run git clone and then paste that URL that I just copied. So basically git clone and then this URL in this format, and the result of that will be that it is cloning into a folder or subdirectory called STM32 fun_test, because that is the name of the repository that I created. And I mean, that can take a little while to do this, but I needed to demonstrate it. Later in this video, I'm going to do a couple of things that take a lot of time, so I might actually make some jump cuts in this video where it just cut a bit of waste out, but I mean, this should be fast enough to and I can probably find something to talk about. Meanwhile, while that is running, let me go over here under myself, and I'm going to run STM32 CubeID. I'm going to fire that up. Now we are done. So let me fire up STM32 CubeID, and when we get into that launcher, you can see it always suggests the last one that I want in. But if I want to work on this new one, all I can do is I can say it was called temp, and it was STM32 fun_test. Let's launch it in that folder. This maybe, as I said, there might be some jump cuts here. I don't know, because first time you start it up in a new folder, it might take a little while. Now, because I have not worked in this as a workspace before, and the workspace itself is not committed to Git, I will start up with a completely blank one here, and in order to get this started, I will need to open the projects from the file systems, and I will use the same one. My folder is temp stm32 fun_test. There we go. These are all the folders that are in there, so I click that and it will all start to show up here. This will take a little time. Okay, it opened all the README files. It's actually quite irritating. Let's close all these windows. Now, let's assume that I am a completely different person and I want to start working on MP3 for the music player. So what I would do is I would find down here, I would find the, no, Yeah, that one. That is the old project, the latest project of the music player. I would, or let's say I would put a display on it or something like that. I don't know. Copy. I'll copy that and then I will paste that back and I will call it something else. Let's call it um, STO fat MP3. Let's use that as a name. So we copy that. So here we have the new folder. As usual, when we clone a folder like that, we need to, well, we don't have a debug folder here, but we need to rename this file. Um, where is rename? Is up here. So fat underscore mp3. So now we have a new folder essentially with mp3. I don't know what changes to make. We could actually add, just for fun, let's add a README file. So let's make a new file and we call it readme.md. There, and we just add test. So I have now created a new file. Let's say I did some work. I don't really know. It doesn't matter, but that is basically a change I made. I'll show you later. I'll leave this open because I'm going to show you how to work with another feature a little bit later. But normally what I would do is I would go in here to my STM32 fun test folder. This is here, and you will see in here the new folder should be here somewhere. It is up there. That is the new folder that I just created. So the workflow in here would be that I do a git add asterisk. I'll add everything. I'll do a git commit everything all. And here you will see my changes on the master. You will see that it is essentially that new folder and all the files in that folder is being added. So you add some kind added MP3 version in cloned project in fork. Don't know. And so now it has been committed to my local. I can do a git log and it will show you that the latest log entry is that I created an MP3 version in clock. And you can see this is the master branch on my, but the master is down here. So if I want those changes shared with anybody else, I would do a git push. And that basically push my changes to the server. So now I have pushed those in. If I go up here in my web user interface in LB Thompson STM32 fun test, you'll see if I do a reload here, first of all, you can see that this branch is one commit ahead of, because now I made a change in my personal branch that has not been included in the master STM32 world STM32 fun repository. You will see down here that the new folder is here. You will see if I go into that folder, you will see that there is a README file which wasn't there earlier, and GitHub web user interface will always show a README file. That's why I call it readme.md. It will always be shown down here. So there could, of course, have been a million other changes in this repository. You'll also see if I go back here, you'll see that everywhere you go, you can see when it was committed and you can see the last commit message for that particular folder. So You can see if we find it down here, you can see, okay, I was lazy there, but you can see added MP3 version 2 minutes ago. Now, this is all perfectly okay. And if you want to work with your own stuff in this way, in this manner, that is definitely how you should do it. But, if you want to ask me a question, I mean, you can send me a link to this and say, have a look at this. This does not work. And it will make it an easier way to change me. But if you actually fixed a bug, if you spotted a bug in any of my repository, and believe you me, there are many. So go hunt for them and please, by all means, do what I'm doing now to demonstrate how this can be done. So what you can do is here, you can see there is one, so you can contribute. So what you do is you click on this contribute button and you see this branch is one commit ahead of this one. You can open a pull request. Now, if you open a pull request, you immediately get redirected to STM32 World Fun, where it will have created a template for pull request. Added MP3, that is the title because that was a commit, but it could be something else. And yadi, yadi, yeah. So you can add a description, and I strongly encourage you to add description. You can even, yeah, well, I mean, you can do a lot of things, and it will basically show you all the changes down here. And of course, this one contains a lot of files, so there will be a lot. So once you're happy with this, you simply click this button, create pull request. Now you have created a pull request. Now let's, in this one, let me go back to here. Let me go back to this one. Now I'm here, and let's see, it shouldn't be, yeah, okay, it still is, of course. So you can see this branch is one commit ahead of still, but you have created a pull request. So now you wait for me as STM32 World to come into my GitHub, and I will notice that there is a pull request. Whoa, whoa, whoa. So I click on that pull request up here, and I see, okay, somebody added an MP3 version in clone project and in fork. So I can click this. Well, okay, there was one more. Number 2, open one. You can see it was opened by me. No, it was opened by LB Thompson, not STM32 World. So I click on this, and I get some information. I can see the description that you did. I can click over here on the commit tabs, and I can see all the changes. There could be more than one commit in a pull request. I can see which files are changed. There is 132 files that has been changed, and I can see, well, it won't conflict with anything. So I can, in principle, just accept that pull request. So if I'm happy with the pull request after I analyze it, I can say, well, merge this pull request, and I will commit a message into the STM32 World repository that I do a merge pull request to from LB Thompson master. That is where it comes from. Extended description and commit email. So I confirm the merge, and now it has been merged in and is marked as closed. So now if I go over to the code, you will see that my repository, or the STM32 World Fun repository, now includes this, which was committed 6 minutes ago with a README file in here, test, 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 and that is all. If I now switch over to the person who did this pull request and try to refresh the GitHub repository, you'll see that now I'm actually one commit behind, because my commit has been accepted upstream and has been merged into their repository. So I will now need to sync the fork update branch, and that should go cleanly because it's my own commit. So now it's up to date. So now the two repositories are completely up to date. Now, if you just want to work temporarily on this, as I want in this case, you can simply delete this repository now. You can also leave it. It's as long as you have public repositories, GitHub is essentially free of charge. So, I mean, you can leave it there, but you can also nuke it if you don't want to work with it anymore. Now, let me show you one other way to work on this. Now, you might have seen in some of my earlier videos that I had this feature enabled. But the reason why I don't normally have it is because I don't like using it. But let me show you anyway. There are some people that are absolutely allergic to command lines. I like command lines. I've been using command lines for the last 40 years. So I have 45 years. So I have no problem with that. So, but I mean, if you prefer to use a point and click interface, what you can do is you can go in here and you can look at the Eclipse marketplace in STM32 CubeIDE. Now, there's a lot of stuff in Eclipse Marketplace, and I would love to find a better one than the one I'm using, because the one I'm using is not very good. Maybe GitHub Copilot is better. I have never tried that. But what I usually do is up here, I will search for Git. There, and I tend to use the one called eGit, JIT integration for Eclipse. So it's Eclipse JIT. And let's click on the install button. It will probably find a lot of dependencies, and I am happy with that. So I say confirm. I need to accept. Did anybody ever read these licenses? I don't think I ever read one in my entire life. So just another waste of time, another waste of time. So click, and this is where there might be a jump cut, because this takes usually a bit of time. So let me stop actually and restart again when I have it. And we're back, and after a while it will come up and say, do you trust these signers? I usually say select all and trust selected. And now I think it will immediately tell me, do you want to restart STM32 CubeIDE to apply the changes? So I restart now, and it will restart. Should be fairly quick. I don't know why right now it popped up on my other screen, but I think it'll come back here. Starting, and there we go. It's coming. It's a bit slow. There we go. So now it is. I have installed that extension. You might have to, let's try to exit and restart it again. It should actually start to find the repositories. And I'm still working on my temporary one down here. Keep that in mind. Okay. This is a little weird. Let me try an experiment that might actually do this trick. I've seen that happening before. If I go over here in my Project Explorer and I do something brutal here, and that is remove all these 65 projects from the workspace, but I do not delete the projects. They will still be on the file. So if I say OK to this, it will basically go back to when I started the first time, and then I open these projects. I will still have that folder, that I used the last time up here. So now let's try to finish, and now it will, now it works. Okay, you might have to have that installed in your STM32 Cube IDE before you open a new project. But the interesting part that you will have now is that you see over here in the Project Explorer, there is a change, and that is that you can see where is that new project. It is here. You can see that it is STM32 fun underscore test master branch that we're working on. Now let's make an experiment down here. Let's let's kill all these that open, which are just as annoying this time. Here we go. Now let's say I don't want this file, so let me try to delete this file. Delete from file system. Okay. So now you will see that it changes slightly. You can see that there's a little greater than sign there, a little arrow kind of thing, and that indicates that this project, it's probably easier to see, has been changed compared to the JIT. So this has been modified. This folder has been modified. So let's go, and this is one of the reasons why I don't use this, is I don't really like this user interface. But if you right click here, and there might be a better way of using it, it could be, but down here we have, where is it? Team. Right, and down here you have all those JIT commands, so you can basically decide, okay, I want to commit these changes to my local repository, and we do that. And this is one of the things that really irritate me in GitHub, that it ends up down here where you can't actually see. Can we actually drag this somewhere else? We could potentially drag it up here. No, let me try something else. Let me try to open a file, so we actually have a file open. Main. There. Let me see if I can drag this up. Can I put it on that? I can actually do that. That might be okay. So we have some unstaged, we have a stage change. We have changed this file. I am the author and the committer, and what we can do is over here we can say, okay, removed readme, and I commit these changes. I can actually commit and push. So pushed to, it has been pushed and it was rejected. Not sure. We push had that. It's still rejected. Let's go down here and under theme and say we want a, let's try to pull to make sure it's up to date. You can see my local commit now. Was that the problem? Yes, I updated. Remember, I did all that. I did the pull request, and I did that merge back. I didn't update my local repository here, so the master was actually ahead. So now I have pulled the changes from the GitHub into my local request, and you can see now I should be able to push my head to the master without a problem. Branch master, and there, push. So now I'm pushing that up. I can push now, and you can see this time it was successful. there. Now let's minimize that and look at GitHub. Now we are the person doing the STM32 world test, and let's look at what happened. This branch is now 2 commits ahead of the master, and let's go down and look at this folder, and you can see in that folder the readme file is gone. So now you have to keep in mind, and yeah, I do understand this can be confusing, but believe you me, it's a lot less confusing than sending files around in emails and chats and attachment in forums and stuff like that. This is still easier. So please do it this way. Now, if I think, okay, that README file was a mistake. I actually added my account number in there or whatever. So now I need this to be committed to so I can open a pull request again. Remember, if it's in your local fork, it is unknown to the STM32 world, STM32 fund. So in order to make it known over there, you have to create a pull request. And you can see in this case, because there's more than one commit in this pull request, there's no title because there was 2 different ways. Removed readme. Removed readme. And create the pull request. This was all done on, go back to LB Thompson. This branch is still 2 commits ahead of the master branch, so we go over to this one, code. There should now be a pull request, and there was indeed a pull request, and I can see, okay, that's fine. Let's look at this one, and I merge that pull request in. No problem with that. So I will merge that pull request and say confirm merge, and it close the pull request. I didn't click, and it closed the pull request. So here you go. This is the general workflow with GitHub. This video is of course a little more confusing than it should be because I played both sides of the but normally I would be probably STM32 world, STM32 font, and you would only be the user that used that half of it. So it is less confusing, but what you need to do is you need to check the GitHub repository and keep an eye out of these messages up here. This branch is 1 commit behind because my pull request was accepted on the other side, so you can sync the fort update branch. Now this is update. Remember now that you updated this, which is the GitHub, the server, the repository. Now this one down here is out of sync, so you also need to pull your local repository so that it is in sync with GitHub. So let's look at git log down here. You can see author was this, merge pull request, remove readme has been accepted into the head from there into master there and has been accepted. Confusing perhaps, but as I said, much easier than handling individual files floating around on the internet. So please, for your own sake and for everybody else, use JIT when you're doing any form of development. It doesn't matter what I do, I will put it in JIT. You have the option of making private repositories on JIT. Of course not if you fork from a public repository, but if you make your own stuff, you can make a private repository on JIT, and it is really the way to deal with these things. You will never lose anything, and well, it's really that simple. So that's about it. This was probably a fairly long and some will say boring video, but I can promise you one thing, whoever's still around now, you will be the good guys in the future. It's that simple. Please, please, please use GIT. Like and subscribe down below if you think that you learned something from this, if it made you a better man in any way, shape, or form. And as usual, please have a wonderful rest of the day. Bye bye.